2, 1, go.
Assalamualaikum and hi everyone. Today we are going to discuss about the usage of mechanic in our real life. So, what is mechanic? Mechanic is a branch of physics that study about the motion and behavior of objects under the influence of force. It also includes objects that are at rest when the force acting on them are balanced. In mechanic, one important concept is torque, also known as the movement of a force. Torque is the turning effects produced when a force acts about a pivot point. The amount of torque depends on two factors, which are the magnitude of the applied force and the perpendicular distance from the pivot. So, in this project, we apply the concept of torque into the real-life situation, which is lifting a heavy object such as water bottle or a dumbbell. Even though the weight of the objects remains the same, the effort required change depending on how far the object is from the shoulder, which acts as the pivot point. Now, we already understand what torque is it, right? So, let's look at the formula to use to calculate. So, the formula is tau equal F multiplied by D. Here, tau represents torque, which is measured in Newton meter and M. F is the force applied, measured in Newton N, while D is the perpendicular distance from the pivot point, measured in meters M. As shown in the diagram, the shoulder acts as the pivot point. The water bottle represents the load, and the distance from the shoulder to the bottle is the perpendicular distance D. From this formula, we can see that the torque depends on two factors, which are the magnitude of the force and the distance from the pivot. Therefore, if either the force or the distance increase, the torque also will be increased. This explains why holding a heavy object further away from the shoulder requires more effort than holding it close to the body. This is the concept that will be used in our study case and calculation.
For this discussion, our study aims to demonstrate the principle of moment where the moment is equal to force multiplied by the perpendicular distance. We want to show that changing the distance of a load from the shoulder, which acts as the pivot, changes the torque on the muscle even though the weight stays the same. Next, the problem we want to solve is why holding a water bottle with a straight, extended arm makes our muscle feel tired quickly, while holding the same bottle close to the chest feels much easier. By calculating the moment of force, we can prove that a shorter distance produces a smaller moment, which reduces muscle strength and help prevent injury. Finally, I would like to ask two questions. First, can a light object feel heavier just because of how we hold it? And is shoulder pain caused by the weight itself or by pure posture that create a larger lever arm?
As you saw in our video, that water bottle feels so heavy because of something called torque, or the moment of force. This is just a physics way of describing a turning force. Think of your shoulder as a pivot point. When you hold the bottle far away, you are creating a long lever. This makes the weight of the bottle pull much harder on your shoulder. We use a 6 kg bottle for our maths. Here is how we calculate the difference. First, we find the weight of our 6 kg bottle. We multiply the mass by gravity 9.81 to find the downward pull in newtons. So, 6 kg multiplied by 9.81 equal to 58.86 newtons. Next, we measure the distance from the shoulder to the bottle. When the arm is straight out, the distance is 0.6 meters. When the arm is hugged close to the chest, the distance is much shorter, just 0.05 meters. Finally, to calculate the turning force, we multiply the weight by the distance to see how hard your shoulder has to work. Case 1. Arm straight out. 58.86 Newton multiplied by 0.6 meters equal to 35.32 Newtons meter. This is a large number, which is why your shoulder feels so much strain. Case 2. Arm hard close. 58.86 newtons multiplied by 0.05 meters equal to 2.94 newtons meters. This is a tiny number, which is why your arms stay relaxed and comfortable. So, by keeping the weight near your center of gravity, you stop your muscles from getting tired or strained. Even though the bottom weight is the same, the turning force dropped from 35.32 down to 2.94 just by changing the distance. So, remember this. The next time you carry something heavy, keep it close to stay strong.
To wrap everything up, our case study perfectly illustrates how simple physics dictates the limits of our own bodies. When held at 6 kg water bottle straight up, they were not just fighting its 58.86 newtons of weight force. They were fighting a massive mechanical torque of over 35 newton meters, because the distance from the shoulder joint to the bottle was at its maximum of 0.6 meters. The shoulder muscles has to work in overdrive just to keep the arm level. However, by hanging the bottle tight against the chest, we drastically shortened that distance to just 0.05 meters. This minimized the torque down to a tiny 2.94 newton meters, shifts the load smoothly toward the body center of gravity, and completely eliminates muscle strain. Whether you are lifting weights at the gym or picking up heavy box, always keep the load close to your body to save your joints and muscles from unnecessary torque. Thank you.